Hello guys, this is a new video where I will try to describe certain cell flags that are very tricky to use but very useful for certain kinds of effects, especially for capturing a rectangular subregion from a bigger bitmap and rendering that one instead of the original bitmap. And I had this idea for this video after I was talking to in our Discord. There's a new homebrew coder, and by the way, just to shout out to his channel Retro Love Letter, where he develops a raycaster for 3DO, and also started some really nice 3DO tutorials besides mine. That mine are posted anyway. And this one are shorter and maybe better. Some things are explained better. But anyway, I have had this idea for the topic I want to talk because we were discussing about his raycasting project and how he initially used software render for the sprites because the sprites are clipping against the walls. But then he used the CEL engine anyway. Also, there are different ways to approach this problem, and to explain you what I mean, I will show you this one. This is a screenshot from Wolfenstein. Actually, it's from the secret level in Doom, the Wolfenstein secret level. I just had to take a screenshot. And this character is partially occluded by the columns. And one approach for if you have a full bitmap on the cell, one approach would be to split to separate column bitmaps and render column by column, so each cell would be a different column. And maybe that's one approach that it's used by his raycaster. I don't know. But there is another. If you have a full bitmap in the cell, but it's partially occluded, you can select a region of it. You can have the original bitmap data in memory, but by manipulating certain cell flags, you can select a subregion. It has to be a rectangular subregion, and that might work for Wolfenstein because there are no heights and enemies can only occluded by the walls, by the wall columns. And if you know the horizontal position where they are occluded, left and right, it could also be right. Then you can manipulate certain cell flags. But that's not, it's not easy if you are in Doom. Because in Doom, you see, there is also occlusion from the floor heights or the ceiling heights, it could be. And there is a diagonal occlusion. See the columns, they have different, they're occluded differently on every horizontal position. And Doom does that. Doom draws separate cells as individual columns from the original bitmap data. But my thought is that if you are making a Wolfenstein raycaster, you might not need to split the masters in columns necessarily. You might be able to get a full region of a bitmap. And to do this, there are certain flags here. Okay, oh, I have to zoom that. So there are certain flags on the cell data structure that is able to get you, if your whole bitmap is this face, you can get a sub window cell that is pixel perfect. But I will show you which ones are they, and I will show you where I go to get the stuff. Usually I go here, programming 3D graphics. There are so many things here, but usually I'm I'm using this one working with the CCP and the preambles. It's the preambles that are very important. So that's the CCP structure. I have explained it before. And besides the regular flags, and the only one we might alter is the source pointer, which is the pointer to the bitmap data. But because this is word aligned, it's going to be rough. You cannot be pixel specific. To be pixel specific, you have to use those last two flags. All these are 32-bit integers. Pre-0 and pre-1 preamble, and this has a lot of bit information. By the way, this is a bit broken. This is not 20. This is 2-0 bits 0, 1, 2. This is from bit 16 to bit 23. See, this is a bit. Those docs are a bit broken. So, and maybe it's better to first show you with this picture I created. So the original bitmap might start here in the upper left corner. And the first thing you would think is, okay, I will change the source pointer. The pointer that points to the bitmap start address. So I will move it horizontally and also vertically. Just to move this corner. But as we will see later, this address is 4 bytes aligned. So if this picture is 8-bit per pixel, you can move only in chunks of 4 pixels on the right. Now, if the width is divided by 4, well, you can vertically move line per line. It's easier. So this is not enough. The source pointer of the cell is not enough. So there is a special preamble 0 flag skip x. And skip x, which are these 4 bits, a value from 0 to 15 that asks the cell engine to skip that number of pixels at the beginning of its row. So you can smooth offset the rendering. You can go to pixel 1, pixel 2, pixel 15. You can combine the source pointer. Now, if this is 8-bit, it's going to be 4 pixels. So you can combine, you can move to the next word, and then you can change the skip x to go from 0 to 3. 0, 1, 2, 3, 0, 1, 2, 3. You don't need to go further. But if you had a bitmap that is 4 bits per pixel, 2 bits per pixel, you would need to go further. And actually I have noticed if you use 1 bit per pixel, you cannot have fine control because it's 32 bits per word, and this goes only from 0 to 15. But who uses 1 bit per pixel, 1 bit textures? So this is going to move horizontally and also vertically. So if this if the width is 128 pixels and this is 8-bit per pixel, it's 128 bytes. That divides perfectly with 4. So it's 32 words. So you can add 32 to go to the next scan line from where the bitmap starts. So moving a vertical region is easier, but the horizontal, you really needed the skip x. And now, the other thing is the width. You might not want to get the whole bitmap, you might want to get a region. And this is defined by this one, in the preamble one, TLHP count, second preamble word. The value says number of pixels in each row of the cell source data minus 1. You always subtract 1. So if this value is 0, then it tells that my bitmap is the width in pixels is 1. We will see it. We will see all these things later in an 3D application I made. It will be more. You will understand it more. But this means that if this bitmap was 128 pixels, this value would this value would be 127. And we also have a value for the vertical, v count on the pre-0. The number of rows in the cells -1. So the cell renderer would start rendering, and then you can alter this value, and it would stop. The counters would decrease till it reaches 0, and when it reaches 0 for the vertical and the horizontal, it will stop. Now, when it stops in the horizontal, if you start from here and you stop here, how does it know? Since the data of this texture are serial in memory, how does it know to not continue from here but continue from down here? This is happening with the W offset. This is, okay, when I finish rendering a row, even if I finished prematurely, how much to add from the beginning to go below to the next data? And this is going to be the greater length, the W offset, which is here, and there are two values I'll tell about. This is the number of cell data words, where words are 32-bit values, 4 bytes, from one row pixel to the next row of pixels -2. It's -2 for that also tells us that the smallest bitmap width you can have in data, in words, is 2 words or 8 bytes. So that could be 8 pixels in 8-bit per pixel texture. In a 16-bit per pixel, it will be 4 pixels. So you have this limitation. But you can render a texture that has width of 1 as long as you have some dummy bytes at the end to be minimum 8 bytes. So a bitmap scan line can be 8 bytes, then 12 bytes, 16 bytes. Then it goes word by word, 4 bytes. But it has to be minimum 8 bytes. That's why you have the -2. So if this has a value of 0, it really means 2 words. So, and this way, even if you render a subregion, the cell knows where to jump. It will not continue from here. It will jump here and goes here to the next line here. It will render the subregion and it will jump. It will render the subregion and it will jump. And it's better to show you a little example I made. This will make things very clear. And here, on the upper left side, this is the original bitmap. I just show it for reference, but the one we will be manipulating is this, and these values have to do with this one. So you see the source pointer, it's in hex points, and I will move it. You see, I move it further, but then you start seeing garbage, and that makes sense because after the bitmap data and before there are different data that are not. But see, it goes for 5C to 60. It goes for 60 to 64. This is the address in bytes. And see here, see, 1, 2, 3, 4. It will go here. It jumps 4 pixels because the bitmap happens to be 8-bit per pixel. You even see it has a bit of threshold. I had a 16-bit BPP version, but I decided to make an 8 BPP to load an 8 BPP cell so that you can see it wasn't clear with the 16-bit that when I increase the source pointer, you cannot give it 61 or 62. Maybe it will clamp the lowest value. It has to be word aligned, 4 bytes aligned. But you see, you cannot have a coarse movement. If you want to have a coarse movement, also with some other keys, I'm moving it vertically. Because I add as many words as there is in one line to move below, and you see the memory. But horizontally is very coarse, and now I have to run it again, reset, so that I don't have a reset button for the original values. So as you see, we can move pixel by pixel if you want to capture the exact pixel position. But we have the schematics and see what it does. That moves pixel by pixel. It goes from 0 to 15. Do you see it? So if I want to move on the pixel position 5, I will go one word to the right, and then 1, 5. Exactly, so that I touch this blue hair here. See, but in this case, you can also do it with this one. Okay, with the schematics. But the schematics is scrolling from 0 to 15, so you cannot go further. If you want to touch the eye, you will go here. Oh, it doesn't touch the eye. And now I touch the eye. See, so you have coarse control with changing the pointer address of the bitmap start, horizontally or vertical. Vertically it's easier because, and there is not skip Y vertically. It's easier because usually your bitmap would be divided by 4. Depends on your bitmap. If you have a bitmap that is not divided, maybe you have to do something else. Maybe you have to add some padding. But horizontally you have the fine control and the coarse control of the address. And now, this is TLPH counts. Yeah, this is the number of pixels minus 1. So this bitmap is 128 by 128, but you see, this is the number of pixels per row, this is the number of rows. And you see they are 127, not 128, because that's how it's said. If you put the value 0, we will see it. So you decide with this when to stop rendering one scan line. And if you put it further, now what happens? This scan line, it seems like it's repeating the texture, but it's not repeating. It goes one scan line here, and it continues serially in the data, it goes below. Okay. And so, because you tell it, oh, my bitmap has more pixels than the max, so it goes a bit out of the previous row and it goes to the next row below. And if you put it to 0, you see it's one scan line because of this -1 rule. The value 0 means 1. You cannot have a texture that is 0 by 0 pixel. It makes no sense. That's why they encoded it like this. I think the maximum value you can have, according to the bits, is 1024 by, or maybe 2048. I'm not sure. 1024 by 1024. So you have a value from 0 to 1023 if it's 10 bits. Maybe it's 11 bits. But I usually don't need to make such a big texture. And you see the same here. Now it goes to the next bitmap rows and it's out of memory. It's at the end of the bitmap data and it goes below that. It's not here in the screen, but where I have stored them, which of course I have other kind of data. And you see the same here. A 0, 0, 0 value means 1 by 1 pixel. It's faster to do it like this. And here is the magic thing, the W offset. Okay. Now this bitmap, this tells you the total width size, and you see, I might be changing that, but the rest of the scan lines are displaying correctly, and that's because it starts rendering from here to here and skips all those bytes. It jumps the total bytes of the whole bitmap as it's stored in memory. And that's how you can get a region without scrabbling your bitmap data, because 30. Now, W offset has the rule, if the value is 30, it means 30 plus 2. So it means 30 plus 2. This is the number of the words, and each word is 4 bytes. So it's 128, and that's correct, because this is 8 bits per pixel, and it's 128 bytes. So 30 is the correct value for this. And see what happens if you change this offset. This is the total offset of the full bitmap in memory. 29, 31, see? It's cute because it finishes here, and instead of jumping down, it jumps a bit to the right, 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 and renders different layers. If you put it 62, you see a more squeezed version of the bitmap and some random junk data. If you put it 14, because you tell it renders this and then it jumps from here to here. Actually, this might be invalid. This might crash on the real 3D. The W offset, logically, it has to be greater than if this is 128 pixel, based on the TLHP count, it has to be, you could put it here and then you could put it maybe here. Maybe not. Anyway, I might not be good at explaining. This is something for a later video, because I was trying some tricks on Doom, and I was doing some tricks to repeat a certain texture so that I don't have to subdivide the walls, and I realize it works on emulator, but it will get 1 frames per second, and it will lock the CEL engine if this W offset value is smaller than loads. If this depicts 128 pixels and this is 120, it's okay. But if it depicts a smaller width of pixels in total, this can be smaller. I think yeah, it cannot be bigger. This, if I go higher than this, it will lock the CEL engine in the real thing. But see, this is the thing now. You can finally, with these tools, you don't need to alter the W offset. Load the CEL with its original W offset and keep the W offset. Just you select this, you do that, and now you can select regions, and you can take whatever region you want by manipulating. See, isn't that cool? Of course, yeah, that's another thing. So, if you want to scroll a sub window, you see this is moving to the left. You might have to complete it. So if you make, I could maybe show you. I had the, I need to find it. So maybe another. I had the Daggerfall map where I was scrolling a sub-region window of the whole bigger image. The image goes 640 by 480, let's say. Or it was a different size, but it was much bigger than the full screen. And I was rendering a region, and every time I moved this, you know, this right side would be bumping. And if you want to display the same length of window, you have to complete it. It's hard to explain. So if I go like this, I have to complete it like this. If I go like this, I will need to hack this to show you. Actually, maybe we can do it fast. So depending on what you want to do I have it? I don't want. I didn't prepare for that. Yeah, let's see. First of all, I made something. I need to hack the make file because. No, I didn't. Let's see. I don't know if this works. Yeah, it works. Oh, well, I'm listening to the USB disconnect. I hope the. Anyway, I hope my my voice is captured. So I was scrolling through this big picture, and this big picture is much bigger. But I'm doing some tricks with sub-CEL region to get only a window that is exactly the screen size. The image is much bigger. Initially, someone would take the much bigger pixel and render it and position it, offset it, and the screen clipping at the edges will do its work. But this is slower than doing this method, especially if you don't use super clipping. It's very slow if you don't use. If you render a polygon that it's much bigger than full screen, it's going to get slow, man. Unless you use super clipping, that has some problems, and it still is going to be slower. But this is the best method to use those tools I show you. You need to play with these values. Maybe we can see. Not much. See, I'm doing manipulation with the position. Map offset here, X, map offset Y. Okay, I'm doing an end with 1 because I know that the map is... So the skipx goes only 0, 1, 0, 1. That could mean that the bitmap is 16-bit per pixel. So it moves at 32-bit words, and occasionally it has to fine tune 0 and 1 pixel left right, you know. But when I'm doing this, okay, and I'm doing it at 2 positions. Yeah, I have to alter. These are magic numbers. This is old code. Yeah, anyway. But I was using this for scrolling a region from a bigger bitmap to do some faster scrolling of the whole big area. But I was doing it with magic numbers because nowadays I'm using this. I'm gonna just roughly tell you about that. I'm using this mask. These are the masks pre-1. pre-0 skipping, so you have the skippings, and it says it's bits 24 to 27. So 31, 30, 29, 28, 27, 5, 4, 4, 5, 6, 7. So those will be these bits. So you will to get it, I will isolate those bits and erase the next and shift it. This is the shift. This value is 24, so that you shift right 24 to get the value. And I'm doing the opposite thing. I'm ending, if I want to set it, with the inversion of this, and so on, so that these are zeroed in the pre-0, and then I'm mooring the value. This value is from 0 to 15, and then but I shift it to the right, to the left to reach this position and draw it. So this is how you work with this, and those are all these shifts and mask are values on the 3DO API in the header files, and I decided to use them because back in the time I was using magic numbers here. Okay. And I have created some helper functions in some of my frameworks to deal with it. One more thing, I wanted to say a few more things. Okay, there are some details. The W offset. For some reason, if your cell texture is 1 bit per pixel, 1, 2, 4, this is not a G, this is a 6 or 6. If it's less than 8 bpp or 16 bpp, then it's from bit 24 to 31. For some reason, there's if it's 8 or 16 bits, it's from bit 68, 16 to 25. It gives a bit more space for some reason. And the nice thing is, this is, it says 10 bits, this is 10 bits, in this case it's 8 bits, because the bitmap is smaller and with the same number of words you can fit bigger bitmap offsets. So there are details like that. You need to play with that, okay. I have shown you the schematics, there are the documents, and I have shown you even practical in the application how it works. And yeah, one thing you can do is like on the dagger map, you can pan a bitmap so that you scroll around. And the other thing you can do is, I think, instead of doing it column by column, at least for Wolfenstein, you could possibly, but maybe you have to store your texture in another way. I don't know if it's stored column by column. Also, no, you can, even if it's stored column by column, it might be possible to take a region and rotate it 90 degrees. So you could easily clip the sprite, and Doom doesn't do that. Doom is doing this method. It splits, every column is a different cell texture, pointing at different. Because of the floor, it has issues with. Oh, and another thing. A final thing. I think I need to check that. I am under the impression, and Doom is using compressed sprites, and you cannot use this. You cannot use this with the compressed sprite. I think the compressed sprites are. Is it here? You have these CCB flags. You have the preamble flags that you need. You have a different kind of set of flags that do a lot of things. I think it's that. And this is related to the preamble. I'll tell you why. Packed. Okay, there is a special compressed format where you can it's run length encoding. I have used it. It's more I have made code that takes an uncompressed bitmap and generates compressed format, where you might have a byte that tells the next 60 bytes is the same color, or the next 30 bytes is this sequence of data, or it's the next 20 bytes is transparent color, so skip all these 20 pixels. It works in pixels, or I think it works in bytes, thinking about it, or in pixels, maybe in pixels, I don't remember. Anyway, so if you use packed texture, then this method, forget, you cannot have a subrectangle with the packed, because every scan line will be different length and W offset will be invalid. It won't work. That's why it says here. It's not just that. It determines that your cell texture is of a packed format, of a compressed format. But the thing is, if your bitmap is compressed, then W offset is pointless. That's in pre1, and this is the horizontal, how many pixel horizontal. That's also pointless, because there is a byte in the packed data that tells you this is the end of the raw data. Go to the next line. You can early terminate, and it can be variable. So that's why preamble 1 is pointless when you have packed data. And that's why you cannot use this method for packed data. And I think Doom sprites are packed, and it's render column by. If it's column by column, it's okay, because you can terminate the line with preamble 0. You can terminate early. Let's see that again. Where was it? I missed it. Sorry, this is very unprepared at the end. You can, if your bitmap is one scan line, if it doesn't have a height, then you can say, even if it's packed, then you can abuse preamble 0, pre-0. You can skip pixels. You can reduce. You don't. The V count will be 0. So you can abuse the starting offset, and you can. No, this is. No. Forget what I say. I'm not sure. You can early terminate in the packed data. Okay, maybe I should stop here, because it became so. I want to say one more thing. There is a function on the lib3do. Oh, where is it? There is some auxiliary function, create subrectangle cell, which is supposed to doing the same thing I was trying to do, to grab a subrectangle from original cell data, and it will change the original values. But I noticed, and we have the source code for that, and here is I noticed that it doesn't work. It's broken, and here is a version where I was trying to fix it. Although nowadays I'm using my own functions. I'm trying not to rely on the original libraries. I mean, not the you need the original 3DO library. This is the auxiliary libraries. This is the lib3do. This is like some third-party library, or it's still from 3DO, but it's some additional functions to help you that were not very well tested. and I did some changes. I might not talk much about it. I don't remember what I did. Why it was using the bit per pixel shift and I'm using the bit per pixel repeats for some reason. There were some things not working, and the most obvious, this was a function that was totally, it was published, but it didn't do what it was supposed to do. The most obvious, and I will say that it would calculate this is the source pointer of the cell. This is where the original bitmap data starts. It takes the buffer in a pointer, char pointer buffer. It takes the value, and depending on various things, it offsets it, and depending on the position of the subrectangle and the bit per pixels and so on, does some more offset, and then see, it does nothing here. It does nothing with the buffer, and you needed to add this line, this one, but I have to take the pointer away. You needed to put back the altered buffer value to the original source pointer for this to work. Oh, also I'm thinking, no, you rely on an original cell, and you clone it, you make a secondary cell, and then you paste it on the original. This function takes two, takes a source and a destination. Okay. So it remembers the original source pointer from the source, and it only alters the destination. Yeah, the cell is the one that's returned. So there was this fix, and there were some other fixes with. I'm not sure if it was trying to do something different, but there were other fixes that I managed to make this work. But I'm not even using this function. I was just trying to fix it. By the way, this is also broken, Eller form, and I haven't fixed it, I guess. I don't think I tried to fix it. This is to get a window rectangle on the video RAM, in a video RAM buffer to do feedback effects, not on a regular bitmap. But anyway, I think I should stop now here. Yeah, it's a shame it took me so much with the second half of the video to explain things. I'm trying to make this video short. And I have another video in my mind to show you a trick with these flags I was trying to do for Doom, but I ended up locking up the 3DO cell engine on the real 3DO, but on the emulator it works. And that's it. Bye.